velocity of the bane prime, then multiply by 1 minus cosine of theta. Then pwede natin ito i-factor out the same also nung isa dito. So we can rewrite this equation as force on x. We have the density, area, velocity of jet, then velocity of the bane, then we're gonna multiply this one to v, velocity of jet, that will be multiplied to 1 minus your cosine of theta minus velocity of the bane times 1 minus your cosine of theta. So you will notice here, pwede natin i-factor out yung 1 cosine of theta. So pwede natin i-simplify yung equation. So writing that one, f of x, so we have your density, area. So we have your b minus your velocity of the bane. Then factor out. So we have 1 minus your cosine of theta. Okay. Then this will be multiplied to b, velocity of the jet minus the velocity of the bane, and we can further simplify this equation into, since this one is common, so we can say that cosine of theta, we can say this one now is velocity plus velocity bane, that will be squared. Okay, so since this is all common, or since this one is the value, so remembering that this is the value of your relative velocity of the jet, so we can rewrite the f of x. So now we got the area, density times your area, then we have 1 minus your cosine of theta, then this will be your u raised to square. Now for the y component of force reaction, so we have, again, we have your density, so multiply by the volume flow rate that is being deflected, then velocity 0.1 at y component minus the velocity at 2, your y component. So this is prime multiplied by velocity 1y minus your velocity 2y. Then again, we can express yung velocity, volume flow rate deflected. We have your area, then velocity, relative velocity of the bane, then multiply velocity y dito, then velocity 2y. Okay, so since yung y natin, y component at this point is 0, so we don't have the y component para dyan. So we can rewrite our equation of y is your density, area, and also we can express this one also lately. So this one will be 0, then b2y value niya, so we have b2y, the y component of velocity 2 leaving the jet, so we have your relative velocity of the jet times the sine of theta. So we can substitute that one, we have your sine of theta. So this is, so we forgot to write the u dito, ito yan. Okay, then so this will be 0 also. What we have now is negative na density, area, so this will be u squared sine of theta, then the value ng u natin, which is the change na, so it will be negative density times your area times the velocity of the jet minus the velocity of the bane, that will be square, so multiply by sine of theta. So, let's have a quick overlook ng solutions natin. So, let's a quick review, no? So, starting from here for the force against the moving lanes. Okay. So, we have your velocity entering at p-sub 1, then you have your velocity leaving at p-sub 2. So, for the value of your Q, so not most all, since ito gumagalaw rin yung vane, so not all the water are being absorbed or some of the waters are being deflected by the vane and some are not, so there's a portion of it. Then to get that one, we have the volume flow rate, which is the volume flow rate that is being deflected by the vane that will be multiplied by the area cross-section area ng jet, at this portion kung ano yung section of area niyan, then multiply by the absolute relative velocity of the vane. Then ano nito, for this assuming the figure, so we have ito, so we have the relative velocity of the vane, and this is side going up. Then we have the velocity of the point 2. Then we have also the v1 prime, which is velocity of the vane. Okay, so for the horizontal component of the velocity at point 2, so we have v2x. So again, we have your v1 prime na ito, then plus the cosine, no? Cosine of theta, u cosine of theta, yung values nito. So that will be summing up ng value ng v2x, the x component. Now, for the f of x, again, we have your density. Okay, so this is already been discussed previously. Okay. Now, again, that will be multiplied. So for the vane, so if the vane is frictionless such that the jet, no? So such the jet leaves the vane with the relative velocity of u, so the direction of wind, the direction of theta, so the theta and the velocity are the same. Also the relative velocity entering and the relative velocity is leaving is the same, so there is no frictionless that is being generated at the vane. So again, from the basic equation, we have density, then the volume flow rate deflected, the quantity of water deflected by the vane, then we have the velocity at x, then velocity at 2x. Since yung velocity at 1x, velocity at point 1x is the same as your v, so given that is v, so we can substitute that one in their equation as v, no? You can change that one. Now for the value of velocity 2x, okay, so referring to the figure, we have your v prime dito, no? So velocity of the vane plus the relative velocity of the jet multiplied by the cosine of theta. Now, yung value ng relative velocity of the jet is equal to velocity of the jet minus the velocity of the vane multiplied. Then we shall multiply this one to the cosine theta. Now, for the velocity of the vane plus the I'll call this distribute natin dito sa equation, then we have your velocity, that will be cosine velocity of the jet times the cosine theta, then minus the velocity of the vane times cosine of theta. So we can factor that one since we have your common natin dito. We can factor that one. So we have your velocity of the jet times 1 minus cosine of theta, then plus the velocity of the this is velocity of the vane, then velocity of the jet cosine of plus velocity of the jet cosine of theta. Okay, so nakalito lang. Okay, so from here we can forward to move on na continuation of the equation. So again, yung kanina, so we have this one. So we have yung volume flow rate, no, deflected by the vane, So we have your area, then cross-sectional area multiplied by the relative velocity of the vane multiplied to velocity, okay, at the x-axis, x component, minus the velocity at point 2 leaving the vane, okay, at the x component. So yung value natin ito, so can be expressed as the change in velocity of ng jet minus the velocity of the vane. Okay, so that is the relative velocity. Now, multiply by the value of, so since ito v1x so are the same now, so we substitute the value of velocity of the jet. Okay. Then, since we don't have the y component dito, then yung velocity at leaving the jet, that would be the 2x, so is minus that will be value natin na nakuha mo dito, then substituted it here, so that will be minus. Then we can by using algebra distribution of equation here, so we can arrive dito. So in-expand natin equation, pinasok yung negative sign ito, then dito, then we can factor out which is yung common, since ito is the same also rin nito. So pinagkaiba is a sign convention lang. So we have your velocity of the jet times 1 minus the cosine of theta minus the velocity ng vane times 1 minus cosine of theta. So since ito tsaka ito are common, so we can factor this one. So we have 1 minus cosine of theta times velocity of the jet minus the velocity of the vane. So take na makikita nyo rin, then the same also we have here, same, no? Same yung velocity, the relative velocity, so we can factor this one into velocity of the vane minus velocity of the jet. Velocity of the vane, jet minus the velocity of the vane square. Okay. Then multiply by 1 cosine of theta, then we have the density times area. Okay. Then ito we can simplify, so substitute u, so that will be u squared, relative velocity of the vane. Okay. Then we have the equation, so that this ito na yung magiging reaction towards the reaction of the forces on the x-axis. Now, for Fy naman, since you have your density, then volume fluid deflected by the plane, then velocity y at point 1 at y component minus the velocity 2 at the y component. So we can express this one as area times your relative velocity of the vane. Then this one, so this is Vy, so usually this will be 0, since you will notice here yung velocity of the vane, velocity of the jet, which is your V1, is acting horizontally and it is along or parallel to the x-axis. So we don't have the y component. So that's why it will become 0. Now, minus yung since this one, B2y, so going back to the figure, B2y, ito yon. So we have here the relative velocity of the vane, so which is your, call this hypotenuse niya dito. So we can transfer that one in here. So we can get the velocity 2y is equal to relative velocity times the sine of theta. We have your angle dito. So from the previous figure, katulad ng nito. Yan. So this one. So going back. So sine of theta, then okay, this is negative, so distribute, so be 0, negative yung value. Then u squared, or relative velocity of the vane of the jet with respect to vane squared sine of theta, okay, minus is equal now to the density, negative, no? Area times the we call this velocity of jet minus the velocity of the vane squared 10 sine of theta. So you will notice the reaction is of your Fy is referring to the figure, so that will be downward, pababa. Okay, so we have the downward reaction. Okay, down, War reaction. Okay, so that summarizes the discussion for the force against the moving range.